Myself Rahul Singh, belongs from Kashi Institute of Technology. Today I am going to start the topic nature of complementary function. This is called as also CF. It is of unit first engineering mathematics 2. So we can start here nature of complementary functions. So we have three parts. First is nature, second is roots, and third one is CF. It means complementary function. In short form it is written as CF. So in first, roots are real and distinct. Suppose we have two roots m1 comma m2, and the roots are real and both are distinct, means m1 and m2 are both different and both values are real, then complementary function is c1 e to the power m1x plus c2 e to the power m2x. If we have two roots, suppose we have three roots like m1 comma m2 comma m3. These all roots are real and all are distinct. m1, m2 and m3, all three are distinct. So we can written as CF as c1 e to the power m1x plus c2 e to the power m2x plus c3 e to the power m3x. Suppose we have four roots m1, m2, m3, m4, and all roots are distinct and real. So CF is written as c1 e to the power m1x, c2 e to the power m2x, c3 e to the power m3x plus c4 e to the power m4x. These all roots are distinct and real. For various roots there is various CF. All roots are real and distinct. Second one is nature. Roots are real. Roots are real and same. The nature of roots are real and same. It means roots, suppose we are taking m1 comma m2, two roots. So m1 and m2 are real and both are equal. It means m1 equal to m2. So its complementary function or CF is called as c1 plus c2x e to the power m1x, c1 plus c2x e to the power m1x if the roots are real and same. Suppose we have three roots m1, m2 and m3. All three roots are real and all three are equal, means m1 equal to m2 equal to m3. Then CF is c1 plus xc2 plus x square c3 e to the power m1x. We raise only the power of x when roots are increasing and there is one arbitrary constant like x square c3 when we have three roots m1, m2 and 3. Suppose we have four roots m1 comma m2 comma m3 comma m4. These all roots are real and all are equal. It means m1 equal to m2 equal to m3 equal to m4. Then CF is c1 plus xc2 plus x square c3 plus x cube c4 e to the power m1x. So these all are the roots are real and same. Third, complex roots. Complex roots, suppose we have the complex roots in the form alpha plus minus iota beta. So for complex root, the complementary function RCF is e to the power alpha x. E to the power alpha x, it means here it is real part, e to the power alpha is real. Bracket C1 cos beta x plus C2 sin beta x. Beta is coefficient of iota and alpha is the real part. So e to the power alpha x, C1 cos beta x plus C2 sin beta x. Now next one is, suppose we have complex roots and same. We have complex roots and same, like alpha plus minus iota beta, comma alpha plus minus iota beta. We have four roots like m1 equal to m2 equal to alpha plus minus iota beta, m1 equal to m2 equal to alpha plus iota beta, and m3 plus equal to m4 equal to alpha minus iota beta. We have four roots here. So two roots are same, two roots are same. So the complementary function for complex root and same, it can be written as e to the power alpha x c1 plus x c2 cos beta x plus c3 plus x c4 sin beta x. If roots are repeated one time, so there is c1 plus x c2 and here also c3 plus x c4. Next one is irrational roots. Irrational roots, it means a plus minus under root beta under root b. It means m equal to a plus root b and m2 equal to a minus root b. Then for irrational root, the CF is can written as e to the power ax c1 cos hyperbolic under root bx plus c2 sin hyperbolic under root bx. It is for irrational root a plus minus iota, a plus minus under root b. So for that, e to the power ax c1 cos h under root bx plus c2 sin h under root bx. Now next one is repeated irrational roots. Repeated irrational roots means a plus minus under root b, comma a plus minus under root b, like m1 equal to m2 equal to a plus root b and m3 equal to m4 equal to a minus root b. So for that, the complementary function is e to the power ax c1 cos hyperbolic c1 plus x c2 cos hyperbolic under root dx plus c3 plus x c4 sin hyperbolic under root dx. It used when the roots are irrational and repeated for that, the complementary function become e to the power x c1 plus x c2 cos hyperbolic under root dx plus c3 plus x c4 sin hyperbolic under root dx. So these are the total 6 cases of the complementary function, and from various six conditions we are finding the complementary function one by one by the process, by the using this formula. And for that we have first clear about the roots, which type of the roots, and then we can declare easily complementary function. Okay, thank you so much. Thank you so much.